Hey everyone! In this video, I would like to take a look at some of the basic angle relationships and also how we can use those angle relationships to write and solve some equations. So I want to start off by looking at a few of the angle relationships. There are definitely more than this, but these are some of the most useful ones. So starting off with the linear pair postulate. So this postulate says that if two angles form a linear pair, then they are supplements. So let's put a diagram with this so we can make sense. So remember, a linear pair, the definition is this is two adjacent angles that form a straight line. So for example, here angle 1 and angle 2, they're forming that straight line, so they form a linear pair. Now this postulate says that if angle 1 and angle 2 form a linear pair, then the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees because they are supplements. So this is the postulate that says that this is true. So if I'm working with some angles and I need to justify how I know the angles add up to 180, this is one of the reasons I can use. A second one I want to take a look at is the vertical angle congruence theorem. So again, let's put a picture with this. And just a reminder, vertical angles are these angles that form two pairs of opposite rays. So they're intersecting lines. And in this diagram, we have four different angles. And this forms two pairs of vertical angles. So the ones that are opposite each other are vertical. So for example, angle 1 and angle 3, they're vertical angles, and angle 2 and angle 4 are vertical angles. And the vertical angle congruence theorem states that vertical angles are congruent. So in this diagram, we have angle 1 is congruent to angle 3, and also angle 2 is congruent to angle 4. And with congruence, that also means that their measures are equal as well. And the last one is the triangle sum theorem. So let's put a triangle down. And the triangle sum theorem says that for any triangle, no matter what the triangle looks like, if I add up the three angles in the triangle, it's equal to 180 degrees. So this diagram, we have the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180. And this works for any triangle. So these are three of the most useful angle relationships we have. Now let's use these in an example, and we'll talk about how we can use them to write and solve equations. So here I have a diagram. We have a lot of angle relationships going on, and what I want to do is write and solve some equations to find the values of x and y, and then after we do that, we can actually find some of these angle measures. So the first thing, let's find x. So taking a look at the expressions that have x in them, we have this angle QPT, and the angle TPS. So just looking at those two angles, they're adjacent to each other, they share a side, and they form that straight line. So those two angles form a linear pair. Because they form a linear pair, I know that the measure of angle QPT plus the measure of angle TPS, that has to be 180. So because they're a linear pair, they have to be supplements, and therefore they add to 180 degrees. And now substituting in the expressions that represent these angles, we have 5x plus 5 for the first one, and then angle TPS is 18x plus 14, and this is equal to 180. So if I needed to justify how I know this equation is true, I would say that my justification is the linear pair postulate. But now we have an equation that we can solve. So combining like terms, 5x and 18x is 23x, 5 and 14 is 19, and this is equal to 180. Subtracting 19 from both sides, we're going to end up with 23x is equal to 161. And lastly, dividing by 23, we end up with x is equal to 7. So great. So there's our first variable. Now the second variable, I need to find y. But take a look at the picture. It's not related to any other angle where we can write and solve an equation right away. But I do notice that I have a triangle. So in this triangle, one of the angles has my variable y in it. Another one of the angles has the little red box in the corner, meaning that it's a right angle. So this one we know is 90 degrees. So if I can find this angle RPS, I should be able to set up an equation to find y. So what I can do is, because I have this pair of vertical angles, so this angle QPT, and we already know what x is, that's a vertical angle with this angle RPS. So if I can find one of them, I know both. So let's do a little bit of substitution here. So the measure of angle RPS, that's going to be the same as this angle out here. That's the same as 5 times 7 plus 5. So 5 times 7 is 35. Add another 5, we end up with 40 degrees. So this angle inside the triangle, this is 40. And now that I know that, I know two of the angles. I have this expression that represents the third angle in my triangle. So now I can use the triangle sum theorem to find y. So we have the 40, we have the 90, and we have the last angle 3y plus 14. All of these together have to be 180 because of the triangle sum theorem. So combining like terms, we end up with 3y plus 144 is equal to 180. Subtracting 144 from both sides, we're going to end up with 3y is equal to 36. And dividing by 3, we get our second value for our variable, y is equal to 12. All right, so we know both our variables. So then the last thing, I have a couple angle measures that I want to find here. So what I could do is I could go through and I could plug these values in. So just like we did with angle QPT here. So this angle we found was 40 degrees. Well, if that one's 40, and I know that angle TPS is a linear pair with that, these two angles have to add to 180. So if I do 180 minus the 40, this angle out here has to be 140 degrees. And then this last one, I know that these three have to add up to 180. So if I do 180 minus the 90 minus the 40, this last angle in this triangle is going to be 50 degrees. So that's how we can use these angle relationships to set up equations and solve for some variables and even find some angle measures.